Hello viewers, welcome back. This is subject 28 for EC solutions. This time from the subject analog circuits. So basically 9 questions came from analog circuits in GATE 2022 EC with a good weightage. 4 1 mark and 5 2 marks questions. Let's start with the very first question in this series of GATE 2024 EC from the subject analog electronics. Question number 17 in the official master question given of GATE 2024 EC. Is from basically long channel NMOS transistor. Small signal input impedance. Question number 17 as follows. 1 mark. It is given in the circuit below. Assume that the long channel NMOS transistor is biased in saturation. The small signal transconductance of the transistor is GM. Neglect body effect. Channel length modulation. And intrinsic device capacitance. The small signal input impedance Z in function of J omega is circuit is given as this. CL C1, this is Z in. Looking into this circuit, Z in Z omega. Okay. Right. Options are given as A minus GM by CL C1 CL omega square C1 CL omega square plus 1 by J omega C1 plus 1 by J omega CL. Option B GM by C1 CL omega square plus 1 by J omega C1 plus 1 by J omega CL. Option C 1 by J omega C1 plus 1 by J omega CL. And option D minus GM upon C1 CL omega square plus 1 by J omega C1 plus J omega CL. Right. So basically these are the four options. Let's know the solution to this question. Solution बहुत ही आसान है. We have to just simply apply KCL or KVL. Say this way. Find the voltage, input voltage. Let's say this is input voltage V in. Okay. This is the gate to source voltage VGS across the NMOS transistor. Okay, right, ठीक है. तो applying, as we know, NMOS has infinite input impedance, so the current flowing across through this, and this is zero, into the base of the, into the gate of the NMOS is zero, so this is open. So all the current flows over here, right? The current through the NMOS is given as GM into VGS, I D equal to GM into VGS, right? Okay. The voltage across this gate and source is VGS. So this is VGS. So current through this is what? VGS by capacitive impedance of this CL, that is J omega. That is J omega CL into VGS. So if we write KVL, we write KCL like this, not KCL or nodal analysis. At this node, it is what? VGS by 1 by J omega. That is the capacitive impedance of this. This is the current flowing through this, plus the current flowing to the MOSFET, NMOS. This is GM into VGS, as we all know. That will be equal to current flowing through this capacitive flow impedance, which is nothing but what? Basically, very simple, right? Sum of these two currents, current through this CL will be sum of these two currents, that is ICL, right? Okay. Is equal to, or ICL equal to VGS into GM plus J omega CL. Okay. Now let's write the KVL equation for this. What was this two? KVL mesh analysis. Let's say KVL. What we get? V in. We are dropping minus VGS, so V in minus VGS minus the drop across this capacitive impedance. So ICL times the capacitive impedance. This is what? Nothing but minus J by omega CL or 1 by J omega CL, whatever, equal to 0. Adding KVL across this group. So we will V in equal to VGS plus, you guys use the expression of ICL from here. So it is VGS times GM plus J omega CL times minus J by omega CL is equal to V. Taking VGS common लेते हैं, तो क्या हो जाएगा 1 plus या 1 minus JGM by omega CL. J to minus J is 1, so and omega will cancel, so this will be this is C1, right? No, this is C1. Yeah. C1. This is C1. This is C1. So this is C1 basically. Right. So it will be C1 by Cn. And I is what? No current flows into the gate of the MOSFET, so all current flows through here. So it will be VGS by capacity impedance, which is VGS times J omega CL. Right? Now the input impedance will be what? Z in G omega will be the ratio of the input voltage and input current, both of which are functions of VGS, which will cancel out. VGS कट जाएगा, कॉमन है, इसे लिखेंगे इसको ओमेगा CL प्लस C1 by CL, और नीचे हो जाएगा क्या? VGS times J omega CL. VGS प्लस कैंसिल हो गया, ठीक है? क्या बचा? वन बाई J omega CL, वन को डिवाइड किया इससे, वन बाई J omega CL एक टर्म है, दूसरा टर्म क्या है? J कैंसिल हो गया, और क्या बचा? माइनस GM अपॉन ओमेगा स्क्वायर C1 CL, और थर्ड टर्म क्या हो जाएगा? C1 हो जाएगा, C1 ना, C1 basically, वन बाई J ओमेगा C1, J कैंसिल हो जाएगा, तो माइनस GM बाई ओमेगा स्क्वायर C1 CL, ये CL है, ये CL है। नेक्स्ट टर्म क्या हो जाएगा? C1 कैंसिल हो जाएगा, क्या हो जाएगा? नीचे CL आ जाएगा, तो 1 by J omega CL. So the input impedance, small signal input impedance is nothing but this 1 by J omega C1 plus 1 by J omega CL minus GM by omega square C1 CL. Which basically matches the question, I think option A, minus GM by omega square C1 CL plus 1 by J omega C1 plus 1 by J omega CL. So this is the correct answer to this question is option A. I've shown the detailed steps and also explained how to apply the approach behind the question. Basically very simple. First basic to basic circuit analysis. First apply traces and model analysis. This node and the current through capacitor CL. Then apply KVL in this loop, input loop, to find V in terms of VGS. And I also can be found in terms of IGS. I can also be found in terms of VGS. Right? Applying circuit analysis or across this capacitor C1. So taking the ratio of V input and V in and I in, that is input voltage and input current, we get the input small signal input impedance as 1 by omega minus G by C1 C2 C1 CL omega square plus 1 by J omega C1 plus 1 by J omega CL. This is the option A. So I've narrated or briefly told how to approach and obtain the answer. Hope you understood it. If you have any doubts or queries, please ask in the comments. And that's all for solution to this question. Thank you.